Uh, Hi students, let me introduce myself. My name is Fazal Hameed and I will be delivering the second part of embedded system lecture. The first part of the lectures is already delivered by Forum Javed, and now this is the second part of the lecture. The main topic of this lecture is input and output devices. Before explaining input-output devices, we first have to define what an embedded system is. So what is an embedded system? So embedded systems are the type of the system that are typically used in our daily life. So what are different examples of an embedded system? What are different main components of an embedded system? The main components of an embedded system is typically an input device, and typically the brain of the embedded system is a controller. That may be a microcontroller for small scale systems or microprocessor for large scale system, and typically we then have some output devices. So a typical example of this devices is, like, let's assume we have a sensor. Sensor is an input device. It is connected to a microcontroller or microprocessor, and then it is typically connected to an actuator. So what's a sensor? Sensor take input from the environment. So what are different examples of sensors? The first example of sensor is temperature sensor. Another example is, for instance, pressure sensor. And actuators, the example of actuator is a motor. So now let's assume we will also study some simple examples of embedded system. One simple example of an embedded system is auto door opening system. Auto door opening system. The auto door opening system is a system that is installed at the entrance of block 6 in IST. So now if you look at the entrance of the IST, so this is a door. This is a door. So there is two types of sensors. Like, let's assume there is some sensor. This is a transmitter and this is a receiver. Transmitter and a receiver. The transmitter will transmit a light and the receiver will receive that light. So if a person passes by, so this light will be interrupted by the person and the door will be automatically opened. So in this example, so we are using some sensor. With this sensor is interacted, the microcontroller will generate a signal to the actuator, and in this example the actuator is a motor. So when a person passes through this way, the signal that is transmitted from the transmitter to the receiver will be interrupted. Microcontroller will generate a signal and then the actuator will be actuated, and there will be a motor and it will cause the door to be opened. So this is one example of an embedded system, that is an automatic door opening system. Similarly, now we will study another example example is your air conditioning system. Air conditioning system. Let's assume, so in that air conditioning system, it has some temperature sensor. The temperature sensor will sense the temperature from the environment. This temperature sensor data will be analog. This data will be connected into a digital data. So we will use an analog to digital converter. That data will be connected into a digital data. This digital data will be processed by some microcontroller, and then it will control the room temperature. And with this microcontroller, there is also some another input device, and that input device may be a remote control. Through this remote control, we can configure this air condition. We can set the temperature to a high temperature or a low temperature. So let's assume that if we set the temperature to 25 degrees centigrade, and then if the AC is on for a very large duration, so in this it will make the room cooler. So if the temperature falls below 25 degrees centigrade, the microcontroller will instruct the AC to turn off so that it should maintain the temperature at a certain threshold. Another example. Another example of an embedded system is a line tracking robot. So let's assume a scenario that we have a path. Let's assume this is a path. And this path has to be followed by a robot. So line tracking robot. So the main components of this line tracking robot consist of two sensors. So let's assume that we have a robot, and there are three different operating modes of robot. It can go straight, or it can go in the right direction, or it can go in the left direction. So for this line tracking robot, so we need some wheels. These are the wheels. And we need two sensors. One is the right sensor that is installed on the right wheel, on the top of the right wheel, and we have a left sensor that is installed on the top of the left wheel. So this sensor will differentiate between white and black background. Let's assume that this background is white and this line is black. So it means there are two possible conditions. So if left sensor has a logical 1 value, it means that the left sensor is on the line, and if the right sensor is on the line, so it means it will produce or generate a logical 1. So if left sensor is on the line, it will produce a logical 1, and right sensor is on the line, so it will produce a logical 1. If the left sensor is not on the white background, it will generate a logical 0. So let's assume that we have a left sensor and right sensor. So it means that if left sensor produce a logical 1 and right sensor produce a logical 1, it means that both of these sensors are on the line, and the line tracking robot should go straight. Now in another scenario, if left sensor is 1 and right sensor is 0, so it means that the left sensor is on the line and right sensor is not on the line. Left sensor is on the line and right sensor is not on the line. So we have to turn right. So we need two motors. One motor on the left side and another motor on the right side. So in this case, the motor will turn. So okay, so now we will use. Okay, so we have two motors, left motor and right motor. So in this scenario, the left motor should be stopped and the right motor will be on. So in this case, it will turn right. So that both lines are on the track. So if the left sensor is 0 and right sensor is 1, it means that we have to move the sensor in the left direction in order to keep this robot on the line. And if both the left and the right sensors are 0, 0, the output of the left sensor and the right sensor is 0, 0, so it means that the robot is not on the line. So it means maybe the robot is here. So what we have to do, so in this particular scenario, we have to track the line. So there should be some line searching algorithm. So let's assume that if the robot is here, how he has to search for a line. So we can move the robot in a spiral mode, so that it should find the line, and when it finds the line, one of the sensor, either the left sensor or the right sensor, will detect the line and it will move accordingly. That if the value is 0, 1, 0, so it will turn right. If it is 1, 0, 1, it will turn left. If it's both are on the side, it will move straight. Another example of an embedded system is a missile system. A missile is typically fired from the source location to the destination, and it follows a trajectory. Let's assume this is the trajectory of the missile. And let's assume that this missile carries an atomic, some warhead, at approximately 500 meters above the ground. So how we can estimate this distance from the ground? So in this particular case, we need a sensor. So we need an infrared light. So this missile consists of an infrared light. So let's assume this is a light. So it will transmit the light to the earth, and then it will transmit a signal to the ground, and it will receive a signal from the ground after some time, and based on the delay that it caused, so the signal is sent at time t1 and it is received at time t2. So the total time between the transmitting a signal and receiving a signal is, so the total time is t1a plus t2, and based on this total time, this missile system can estimate the height of the missile from the ground. So when the height of the system, so we should not, so this is also 500 meters above the ground, but we should not detonate the war, we should not detonate the warhead here. We should only detonate the warhead when it achieves the maximum height, and after the maximum height, when it's very closer to the destination, so we can then activate the warhead at this point. So we should not activate the warhead at this point, we should activate the warhead at this point. The